of triangles. Of all the geometrical structures that mathematics can boast of, triangle enjoys a special status. Its importance to the world around us is absolutely tremendous. Triangles are used in structures where the strength and stability are the key factors. In geometry, triangles are the basic building blocks of all two-dimensional shapes with straight sides like polygons, including rectangles, squares, rhombuses, trapezium, and kites. Let us delve deep into the congruence of triangles that will help us learn more about these shapes. Objective. In this session, we will understand the congruence of triangles. Consider some triangles that have congruent sides, that is, the sides of the same length. Measure their angles. You can see that their angles are also congruent, that is, of the same measure. The parts, sides or angles that are congruent are called corresponding parts. Slide around, rotate, and flip over in various ways so that they can make a pie. You can see that they exactly cover each other. Thus, these triangles have exactly the same size and the same shape. Such triangles whose corresponding sides and corresponding angles are congruent are said to be congruent triangles. However, those triangles which are either rotated, flipped over, or mirror images of each other are congruent triangles irrespective of their location, as long as their corresponding sides and angles are congruent. Congruent triangles can also have a common side or a common vertex that is shared by both the triangles. Now, consider triangle ABC and triangle DEF, and place triangle ABC on triangle DEF, such that A falls on E and B on D. Do the triangles cover each other completely? Obviously, they do not. Next, rotate them and flip them over. We can see that they exactly cover each other when vertex A falls on vertex D, B on E, and C on F. That is, A corresponds to D, B to E, and C to F, which is written as A corresponds to D, B corresponds to E, C corresponds to F. Thus, there is a 1-1 correspondence between the vertices of the two congruent triangles. Similarly, there is a 1-1 correspondence between their sides and angles too. AB corresponds to DE, BC corresponds to EF, and CA corresponds to FD. And angle A corresponds to angle D. Angle B corresponds to angle E. And angle C corresponds to angle F. Under this correspondence, triangle ABC is congruent to triangle DEF and is symbolically written as triangle ABC is congruent to triangle DEF. The symbol for congruence is, the symbol is made up of two parts. The upper part means the same shape, and the lower part means the same size. We can write the congruent statement in more than one way. Two possible congruent statements for these two triangles are triangle BCA is congruent to triangle EFD, and triangle CAB is congruent to triangle FDE. But if we write triangle ABC is congruent to triangle EDF, it is incorrect. Thus, it is necessary to write the corresponding vertices in the same order when you represent the congruence of triangles in symbolic form. Now, if we are given the corresponding vertices in the
BCA, చూడండి ఇక్కడ స్టార్ట్ అవుతుంది BCA ఇక్కడ చూడండి B దగ్గర స్టార్ట్ అవుతుంది EFD ఇక్కడ ఈక్వల్ కదా
ఈక్వల్ సార్.
చూడండి సిఏబి సిఏబి అప్పుడు ఏం చెప్పాలి
FDE.
ఏబిసి ఏబిసి డిఈఎఫ్ ఈడిఎఫ్ రాసి ఈడిఎఫ్ అంటే డిఈఎఫ్ అని ఒకటే కదా సార్ అంటే కాదు ఇలా రాసినప్పుడు మిడిల్లో ఉన్నది యాంగిల్ అయింది మిడిల్లో ఉన్నదాన్ని ఏమంటారు యాంగిల్ అంటారు అవునులేదు ఇప్పుడు ఇలా యాంగిల్ ఇలా ట్రయాంగిల్ రాసి ఏబిసి రాసినప్పుడు యాంగిల్ ట్రయాంగిల్ యాంగిల్ అని పెట్టి సింబల్ పెడితే యాంగిల్ బి అని మీనింగ్ యాంగిల్ ఏబిసి అన్నా యాంగిల్ అన్నా ఇప్పుడు యాంగిల్ బి అని రాయొచ్చు షార్ట్కట్లో ఇలా పెడితే ఏబిసి కూడా రాయొచ్చు ఏబిసి ఆర్ యాంగిల్ బి ఈక్వల్ అవునా అదే ఇది నాట్ నెక్స్ట్ ఇవన్నీ ఈక్వల్ తెలుసా నెక్స్ట్ కావాలి
In order, when you represent the congruent